I'll share my screen. Do you know the formula? We'll start with a triangle. What is the area of a triangle formula? Do you know that one?
So you do height times base divided by 2.
Yeah, so there's a few variations on it. Base times height divided by 2, or even like 1/2 base times height, like that.
Yeah.
Okay, so they're the same here. Now, one of the things that could be challenging is actually identifying these things. So for example, if I draw a triangle like this is a right triangle, base 3, height 4. Is this the base or is this the base? Or does it matter?
I don't think it matters, but I think 3 would be the base.
So normally the base refers to what it's sitting on.
Yeah.
Do you know what I mean by that?
Like the one on the bottom.
Yeah. So what it's sitting on is this. Now, depending on the paper you get, you could see something though where it's drawn like this, and this is 5 and this is 12, and now which is the base? And the answer is, well, you really should rotate this figure. I don't even know if this has a tool for doing that. I don't think it does. You should actually rotate this figure so that it's sitting on the base. So this is 5 and this is 12. Do you see how I sort of rotated it that direction?
Yes.
Okay. Don't rotate your head, rotate the paper. Like I don't have a visual element here to show you with that, but if you're unclear which is the base, move your paper around until you settle on what is actually the base. Okay. So that's pretty straightforward as far as that. Now, the area of a triangle really comes from the more general area of a rectangle or a square, which is base times height. If you take any rectangle or any square and you draw a diagonal, do you see that they make 2 triangles?
Yes.
So the area of the triangle is half the area of the square, which is base times height. That's where it comes from.
Yeah, and so that's why when you're doing the formula for a triangle, you have to divide by 2, but rectangle you don't.
Yes. Yes.
Right.
So like when I make worksheets for students, like let's say you and I were going to make a triangle worksheet. Okay. The first type of problem is I would give the base and the height. I would give you those values. And with the base and the height, what could you calculate? The area.
Yeah.
Right? Like those were the problems I just gave you. Do you agree with that? Like I give you the base and the height and you find the area.
Yeah.
Now it could also be though that I give you the area and either the base or the height, and then you have to find the other. Okay, so let me try to explain that here. Maybe that's not clear. Let's say
I get.
Okay. So let's just say that the area is 50, right? And the base, I tell you the base is 5. Or I'm sorry, that's in the wrong spot. Let's say I tell you the base is 5. What must the height be? Well, you would
20?
want to write the form. It would be 20. Yeah, the height would be 20, and you can just quickly calculate that, right?
Mm.
So the question I have to ask you is your instructor giving you numerical problems, or are you given problems like, let's say the area, let me come up with a new problem here. And this is where it would help to have some of your class notes. Let's say the area was 32 x squared. Is your instructor giving you any problems like that?
No,
Are they
it's
just
just like,
numerical values?
yeah, it's just like the shape and base and height. And it's like, what's the area?
Okay, and not, so you see here, like, so like, for example, if I give you the base and the height, you just calculate the area. You just got to know the formula. Is that okay? Is that clear?
Okay.
Do you feel like you understand that?
Yeah. Could you give me
Okay,
a couple of problems with it?
sure. Now let me change these up slightly. Let me add some units. Okay, so we just bought a plot of land. This is 6 miles, and this is 12 miles. And we want to know the area of this
Triangle.
land that we just bought.
Oh, okay.
So it
Oh,
could be in the context of a numerical value, or like a word problem or a story problem.
so 36.
Yes, 1/2, 6 times 12 is 36, but this needs units. So it's miles
Miles
squared,
squared.
or how we say it when we're talking to people is usually square miles.
Hmm.
Both are okay.
Okay. Okay.
All right.
Got it.
Now let's say we want to find, there's a telephone pole that's 50 feet tall, and there's a guide wire going down this way, and it's 80 feet over here. We want to find the area inside this triangle here.
Okay. 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 $2,000
2,000 what? What are the units?
feet squared.
Feet squared or square feet?
Yeah.
You ever been to like a Home Depot or a carpet store or a tile store?
Yes.
That's where you see these kinds of measurements. Actually, interestingly, things like toilet paper and paper towels, they sometimes measure them in like inches squared, or it could be feet squared. It's probably inches squared. You
Mm.
might have seen those there. Um, yeah, so that's
And then
triangles. They're
also,
pretty straightforward. So
trapezoids.
yes, so we'll look at some trapezoids next here. So the area of a trapezoid, this one is much more complicated. So before, not much more complicated, but first, before I give you the formula, let me back that off here. This is the trapezoid you're most used to seeing. Would you agree with that? This is the kind of the
Yeah.
standard one.
Yes.
So here's what you need to pay attention to with trapezoids. The trapezoids have one set of parallel sides. Do you see how these are parallel, and that's why I've drawn the little lines there?
Yes.
Now you're not going to like this, but this is the other kind of trapezoid that you'll probably see on your exam. Is this a trapezoid?
Yes. Because it
Yeah,
has two parallel sides.
one, we call it a pair, or yeah, but yes, exactly. Okay, so you got to be careful that you and again, if you don't like it, I mean, I can't do this with the digital interface here, but if I made this on paper and you don't like the way this look, rotate your paper so that it looks the way you want.
Okay.
All right, so let's go back here. This is considered base 1, this is considered base 2. The bases are parallel, very important here. The bases are parallel. And then the height, well, the height is the height. So the area of a trapezoid, and are you going to have to memorize this?
Memorize the formula.
Yeah, or are they going to be given?
I'm gonna have to memorize it.
Okay, so this B with a little 1 is could be said a few ways. It's B subscript 1, or sometimes you say B sub 1, but what you really mean is B with a subscript of 1.
Mhm.
This is a common thing to do in math. Your instructor might use big little b and big B, fine, whatever you want to use, but this is kind of the standard one with the subscripts here. And it's just referring to one side or the other. Because you're adding, they could go in either order. You don't have to worry about that. And then so variations on this formula, like sometimes it's written like this: h divided by 2, b1 plus b2.
Yeah.
Whatever you want, totally whatever you want, right? But notice that you have to be given now 3 pieces of information to find the area. On this other trapezoid, your height isn't really the height, is it? It's really the base.
Yes.
So you got to be really careful with the wording or the language that the instructor uses. Now, if you ever get a test or quiz or something, and I can get see kind of the type of questions your instructor asks, I could better help you here. The reason is like an instructor could call this a base. They could say it's sitting on the base here, but it's not really the base. It's these 2 heights.
But I just need to know to add the 2 sides, the 2 parallel sides, multiply by the other straight line, divide by 2.
Exactly. You said it perfectly. Do you make note cards? What do you do to remind yourself of these formulas? Like, how are you going to remember this just the way you said it, so that when you wake up in the morning, you know how to find the area of a trapezoid?
Well, he only lets us do note cards if he thinks it's really, really hard. So this one, I'm just gonna have to have a lot of practice at it.
Yeah, and that's what I'm asking, Craig. Do you like to write it down? Do you like to say it out loud? Do you like to put it on a note card, 3x5 card? Do you like to have your dad quiz you? What do you like to do?
My dad quizzed me on it.
Okay, perfect. Great. So when you're trying to learn stuff like this, what's most important is how often, not how much time. So what I mean by how often is like before bed, in the car, kind of thing. That's better, even if it's 5 minutes and 5 minutes, than just doing it one time at 10 minutes. It's how often you do something that's really going to help make the difference here with this. Okay, so let's look at some problems, and I'll try my best here to give you some interesting ones. I apologize, trapezoids aren't all that interesting, but does your instructor like to use fractions or decimals or what? Anything like that?
For like the divide by 2 part.
No, just like in general, does he seem to favor numbers that are ugly, nice numbers?
Sometimes he does just regular numbers, just whole
Okay.
numbers, and sometimes he'll put a 0.5 or point
Okay.
this, that.
Yeah. So here's a good problem here where it's got ugly numbers in some ways. And you probably have to do this by hand. Is that right?
Yes.
No calculators. Okay. So this one, you've got to start with your formula here. Let me kind of frame this a little better. And as a reminder, I'm going to send you a PDF of the notes at the end, and we are recording this. So if you need to, you can look at it later. So like you said, you got to identify the 2 bases. What are the 2 bases here? Greg, are you with me? Greg, let me know when you are back. I am not able to hear you.
Hello?
Hey, Craig,
Sorry, my internet like went out.
no problem.
And like
Are you still able to see? Oh, go ahead.
like my dad's phone went out and everything. Like the whole internet in the house just went out.
No problem. So are you seeing my screen?
Yes, 60, 121,
Yes.
12.5.
And that, yeah, so we gotta take that height. Now, this is where it's like, well, is this too much? Would you, would you expect your instructor to give you something like this?
Definitely.
Okay, that's good to know. So my approach would be to probably cut this 181 in half. It's better generally to divide, believe it or not, before multiplying because the numbers get smaller. Okay, so
So,
eight, go ahead.
oh, so I would just divide all the numbers. Like,
Just this one,
where's 181 from?
181, because you're adding 60
Oh,
and 121 and 121.
121, 12.5. Okay, so add those two, 181.
Do you see that half of 181 is 90.5?
Yeah, I'm just gonna do it the regular way though, cause like it's already like kind of confusing, and I don't want it to like mess me up too much, you know.
Sure, sure. At some point though, we have to do this multiplication here, which I guess we can talk about if we need to.
And why isn't it 181 times 12.5? Then after that answer, you divide by 2.
Because the numbers get too large. It's better to divide before multiplying because the numbers get smaller. It will
Would
make
it
you, it'll make you faster if you do it this way.
would it still work the other way though?
It would, but I think that's a worthy thing for me to try to convince you of. Like, let's say I wanted you to do 1/2 of 30 times 20. If you take half of 20, that's 10 times 30 is 300. Whereas if you multiply them, you have to get 600. You might even have to write it down and then divide. They both work, but some of what we're trying to do is address like how you can do it better and faster and then the right way. Most students do what you just said, though. They want to multiply before they divide, but it's better if you can do it this other way. So let's go back and look at this problem here again, because if you go to multiply 181 by 12.5, boy, that's, I mean, you got issues there potentially. You can definitely stack them on top of each other. I'm not sure how you do your multiplication. You can do them this way where you stack the numbers. How do you like to do it? Or do you line up the decimal
I
point?
just do what's 1 times 12.5. 12.5. What's 8 times 12.5? And then I add a 0.
Okay,
What's 1 times 12.5 again? And then add 2 zeros.
okay, got it. So we should probably not actually spend any more time on this problem because it's if you do get something like this, it is very long to do, but I'm hearing that you do understand it. Let's look at some other problems here, and see if I can, maybe find something else here to talk to you about. So what your instructor might do is give you a problem that they give you a lot of information, some of which you don't need, like 24, 18, 6, and 4. And they might ask you to find the area of this trapezoid. How would you
Yeah,
do that for this one?
I would do 24 plus 18, which is 42. Then I
It
would
is
do
42.
then times 4, because that's the straight line. And
Okay.
6 doesn't matter. We don't need that.
So
So
again, like I would tell you, if you cut 42 in half, because it's easier to cut something in half, that's 21. 4 times 42 is 168. See how much bigger that the numbers got when you multiply?
yeah,
That it does work. Like it's not wrong. I'm not trying to tell you not to. I'm trying to show you that making the number smaller is generally better when you do this.
could you do another problem? And I'll write it down and try to get an answer for it.
Absolutely. Sorry, I'm doing these for you, and then I know you want to work through some of them. Yeah, so let's do that. Let's go. Oh boy, let's go. Sorry, I'm just trying to come up with decent looking one here.
Oh, so that's definitely a trapezoid because only one pair of parallel sides.
Okay. Yes, this is a trapezoid because it only has one pair of parallel sides. Yes.
Okay.
Okay, so go ahead and try to find the area of this one, please.
Okay. $82 meters squared. Is that it? So 3 plus 17.5, 20.5. And
Hey, Craig.
I,
Craig, you there?
yeah,
You
were
there?
you on mute? Were you on
Okay.
mute?
Yeah. Just a brief moment. I was checking to see if you could. I wasn't sure if you could hear me or not. Now you have a choice here. I would take a half of 8. I wouldn't do it of this. I'm not sure what you did, but I would tell you do half of the easier thing, and maybe you multiplied first. I don't know. But if I take half of 8, that's 4. 4 times 20.5. Well, 4 times 20 is 80. 4 times 0.5 is 2. I think that's what you said.
Yeah, 82 meters squared. Yes.
Yes. And getting the right answer is great. It's very important. It is also important to do it the way that is the most efficient. You play sports, is that right?
Yes.
You're doing. Remind me what you're playing. It's a field.
Lacrosse.
Lacrosse, and like when you're in a position on the field and you need to get here, you generally take the most efficient line. Would you agree with that? To get there.
Yeah.
So what we're talking about here is the difference between doing this and doing this. And as you know, the better players, the better teams, you have to take the most efficient path. Now, maybe there's a guy in your way and you gotta do that. But what I'm trying to show you is you can do things in a way where you get the same result, but maybe it's 10 seconds faster, so you get more time to look at something else.
Yeah.
Okay, so let's look at a composite shape here. Kind of. I'll get a true composite shape, but I'm going to just draw this one first. What is this that I have drawn?
That's a triangle.
It is a triangle here. Now watch this. If I put these two positions in, so here there are actually 3 shapes here. Okay, and I want you to find all 3 areas. So there's triangle ABC. That was the first one I made. There's triangle ADE. And then there's trapezoid, which they actually do draw a little trapezoid for it. DE. E B C. Okay, so I'm going to give you some numbers here. Let's go 17, 7, 4, 6.5. And have I given you enough to do everything? Yes, I have. Okay. I want you to find, actually, I made this too difficult with this number. Let me change this to 6. I want you to, as quickly as you can, actually, let me frame this. I want you to find these 3 numbers and assume it's in inches this time. Everything is in inches here. So do you have your 3 formulas?
Yes.
All right, so I'm going to time you because speed is important. Go ahead and start now.
Okay. Okay, I think I got it.
Okay, go ahead and give me your final answers for any 3 of these, whichever ones you got.
Okay, so for shape A, D, E,
Okay.
I got 24 inches squared.
Yeah, you said 24 inches squared.
Yeah, so 7
Okay.
times 6. Wait,
Which
wait,
is
wait.
42.
Actually, no, 21, 21, 21.
21 inches squared.
Yeah.
Okay.
Wait, let me just one check. Okay. For the second shape,
Okay.
for D, E, B, C, the trapezoid, I got 34 inches squared.
Okay. What did you add up 7 and 17?
Oh no, I forgot. No, I didn't.
Okay.
I did 4 times 17. Okay, and well, for the final shape, I got it wrong then if I got that one wrong.
Well, so yeah, I mean, I didn't mean to make you rush. I was just trying to put a little pressure on, but make sure you're using your formulas. Like for ABC, obviously it's 1/2 base times height. The base is 17 and the height is 6 plus 4 because it's these 2 together,
Mm-hmm.
which is 10.
Could you do another one, but like without the letters, and I'll just be like the small triangle, the big triangle, and then like the trapezoid.
I could. The letters are kind of a standard thing that you'll see in geometry. Maybe what I'm noticing is like the more information I put at you, there's a little bit of a distraction. Now notice though, this is kind of interesting. Notice that if you wanted the big triangle, you could have found the little triangle and the trapezoid and then added them together. Now, I'm not saying that's the best approach, but there are different ways to do the same problems. But yeah, let's do another one here. I'm actually gonna change up because I don't want to just give you the same thing. I don't think that that's going to be useful here. So let's give you a problem like this. where this is 25, 16, and 4. And then this right here, I'm sorry, the 25 represents the whole length here. And this, we'll call this 12. So I want you to find the area of the trapezoid first for me.
Okay. So okay, I think I got it.
All right, go ahead and give me the area of the trapezoid.
But for the trapezoid, I got
Yes.
82.
82. Okay, so here's how I would do it. It's 1/2 base 1, which is 16, plus base 2 times the height of 4. 16 plus 21 is, or 25 is 41. Half of 4 is 2, so yes, that is correct. How about the area of the triangle?
For the area of the triangle, I got 96.
So the area of the triangle is 1/2 base. The base is actually 16. Did you see that? The base is this right here.
Yes.
Times 12, the height. And if we take, I'm going to take half of 16 because that's the larger number. 8 times 12 is 96. I think you said that.
Yes, I did. And
Perfect.
both combined, not 60, or not 60, I'm sorry. 6 plus 2, 8. So 178 is the, wait.
Oh, sorry.
No,
I got the
put
wrong number
82. It's okay.
It's it's
178.
it is 82. Yeah, 178. Okay, good. Now here's the only other type of composite that you might see. You might, for example, have a trapezoid like this. And then I got to do it with colors like this. And it wants the area of the blue. This isn't really the best way to show it, but what I'm trying to show you, actually, this is not a good problem here. I'm trying to show you that you can subtract. Let me try this one other way. What your instructor, let me insert. Let me see if I can insert actually the right shape here. No, draw. There they are. Okay, basic shapes. Not useful. Okay. It's not filled in either. Okay. That's not going to work. Okay, so let me just make a really basic problem. So let's just say this is your trapezoid right here. And this is like 50 and 10, we'll go meters and meters. And your instructor could put a triangular window in here and say, well, that's 3 and that's 3 meters. And they could say, well, what's the shaded region? So they're referring to this like region that's and this, we'll call this 40 meters. So to do a problem like this, you actually have to subtract. You have to take the area of the trapezoid and subtract the area of the triangle. Whereas in the previous problem, we added them together.
Yes.
Okay. So like for here, the area of the trapezoid is 1/2 40 plus 50 times 10. And then you would subtract out the area of the triangle 3 times 3.
So 900 minus 9, but so 400.
But it's half. Yeah,
so 450. So 441.
Well, this is 9 divided by 2, so it's 4.5. And then it's meters squared. So you'd get 445.5 meters squared.
Oh, why did you cut the 9 in half?
Because it's a triangle. 1/2 base times height. This is a triangle in here, isn't it?
Yeah.
So that's why it's 1/2 base times height. The base is 3 and the height is 3.
Okay.
So this is 445.5. Hey, is your dad around? Just to give a brief dialogue with?
Yeah. You want me to get him?
Yes, please.
Good.
Hey, how are you?
Hey, Rick. Good, doing well. So good lesson with your son today. We worked on triangles and trapezoids. Every lesson, I'm going to learn a little bit more about him and how to best help him. One of the things that he needs your help with between now and his quiz is making sure he knows the formulas for triangles and trapezoids. And I say it this way, I say, you got to be able to roll out of bed and like know the formula for triangle and trapezoid or whatever you're learning. That's how well you need to know it. So just make sure he knows that before his quiz tomorrow. That would be a really big help for him.
Is that possible to know it well within the next couple hours?
Sure. Yeah. I mean, they're not, they're small formulas.
Okay.
And just what I'm going to start emphasizing, I'm seeing a lot of and there's nothing wrong with this. Craig is very heavy on doing the calculations, which is important. It's just that they sometimes take away from the problems. And I'll just give you a small example here. If we want to find the area of this triangle, and I tell you that it's 2 is the base and 3 is the height, the area is 1/2 2 times 3, no big deal. But if I change the problem, I say it's 2.62 and 3.05.
Yes.
This problem all of a sudden becomes all about the ability to manipulate decimals. And what I'm trying to find out is how much the instructor is emphasizing like the numbers in this class. So if there's any way to get like a quiz or a test or a worksheet that he made, not something he pulled off the internet, that would really help.
I thought you had
me
some
be able to
quiz.
better.
I do actually.
Okay.
But it wasn't on this. It's gonna be tomorrow will be the first quiz we take on this subject, but I do have.
You
What
could
about
send
your
them on
last
past.
quiz? So he said the last
yeah,
test he did.
what it does.
Quiz right here.
All right. So the last test he said, would you get a 90 something? And I said, great. Save that test and let's show you so you know what's going on in Arizona. And he said, well, the teacher took that test back or something like that.
Or he took the test back, but I have the quiz.
So,
Right.
but
So anything you send me gives me like a feel for the way
yeah,
the instructor
an idea what's
yeah.
Yeah.
you know, so we should scan that and send that.
I'll do it right now.
All right.
Okay, so that does take us to the end of our lesson for today. I'll send you the notes and the screen recording here shortly, and we're all set up for next week at a better time. So we'll just convene then.
No problem. You know, today worked out as well too. He had a football game today or whatever like that. So that it ended up working out nicely.
Excellent. Excellent. Well, thank you guys. I look forward to seeing you and I hope you have a great rest of your day.
Okay,
Hey,
great.
one second though.
You should receive, he's sending over some photos right now, so I guess.
Perfect.
Well, I'm
Perfect.
taking pictures of them, and then I'll just share screen in a sec.
Oh,
Go ahead and just send those by email or text, whatever is preferred for you guys. I really do got to run here. Just take a little break for myself. So
Okay.
I will look forward to helping you guys next week.
Okay, fantastic. Have a good week.
Thank you. Bye now.